Good evening to all. Welcome to an NPTEL course Operations Research live and live session. Service the course tutor is Professor Kusumdeep, IIT Roorkee. Myself, Jayana Gasri, PMRF Research Scholar and a teaching assistant for this particular course from the Department of. Okay. Am I audible now? Anyone, please respond in a chat box. Okay. Okay, welcome to the live session of NPTEL course Operations Research, for which the course tutor is Professor Kusumdeep, IIT Roorkee. Myself, Jayana Gasri, PMRF Research Scholar and a teaching assistant to this particular course from the Department of Mathematics and Statistics, University of Hyderabad. Is my screen is visible? Now? Okay. So coming to our problem solving session, here is the first question that a firm manufactures three products A, B and C. The profits are 3 rupees, 2 rupees and 4 rupees respectively to manufacture the products A, B and C. The firm has the fee and also the firm has two missions, and below is the required process time, that is here the table is showing the required time to manufacture the products A, B and C from the two missions G and H. And here they are saying that the mission G and H have at most 2000 and 2500 minutes respectively to produce the product, and the firm must manufacture only 100 A products and 200 B products, 50 C products, but no more than 150 A products. Then our question is, set up a linear programming problem to maximize the profit. So in such a case, first we have to find out what are the decision variables. Here the question is, the field must manufactures given a number of product A's and product B's, product C's. So we can find out that the decision variables are the number of products that are manufacturing from mission A, mission G or mission H. So overall total number of products are the can be taken as the decision variables. So let us suppose that the solution the solution to this problem is to consider first the decision where we have to identify what are the decision variables involved in this problem. Let us suppose x1, x2 and x3 are the three decision variables that the number of products of A's, B's and C's respectively. So next we need to set up an LPP to maximize the profit. So in an LPP, what are here they are also given the profits that 3 rupees, 2 rupees and 4 rupees for manufacturing the products A, B and C. So if the product A can be manufactured, then there is a 3 rupees of profit. So out of the X1 products, we can get 3 X1 profit from the product A. And in the respectively the 2 rupees for one single product B, then out of all number of products is x2 for product B, then we can get 2x2 profit from the product B. And 4 rupees for product C means 4 x 3 you can get the profit from the product C. So the maximum profit comes from when the fin sells all the products. So here is the 3x1 is the profit from product A and 2x2 is the profit from product B, 3 and respectively 4x3 is the profit from product C. So when combine selling all these products, then we can only get the profit. So this can be tell us profit comes from when we are selling all these products. So this is the maximum of P. This is can be seen as it is an objective function. And next we have to find out what are the constraints involved in this problem. And clearly they had given to manufacture a product A. Just a minute. To manufacture the product A from mission G, there is a 4 minutes of time. And in a similar way, to manufacture product B from mission G, there is a time limit of 3 minutes. It can take 3 minutes. And product C can take and product C can take 5 minutes from the mission G. So from mission G, overall time takes to produce all the products is 4 minutes of time for product A. That means all number of product A's are x1, and also 3 minutes of time of product B's and 5 minutes of time from product C's. So and clearly they had mentioned that the mission G and H have 2000 and 2500 of time maximum limit, that are the time of minutes. So I can say this should not over the 2000 of minutes from mission G. And in a similar way can get 2x1 from the mission H, 2 minutes of time to produce the product A and 2 minutes of time to produce the product B and 4 minutes of time to produce the product C. That all number of time should not be greater than 2500 minutes. So these we can say that these two are the constraints which are involved in this problem. And next we have to find out what are the non-negative restrictions. In an LPP we must have an objective function and subject to the constraints. Here we are already find out the subject to constraint. And what are the non-negative restrictions? Generally the decision variables should be greater than or equal to 0. That is the non-negative restriction. Here they said that the product A, the manufactured product A should be 100 but not more than 150. Here we can observe that it's not more than 150 years, but the overall from mission G or mission H it should be manufactured 100 years. So 100 less than or equal to x1 less than or equal to 150. Because x1 is the number of products number of A products. And another non-negative restriction is 200 B's only. So the products should be less than or equal to 2, and C products should be 50, not more than 50. So finally you can say that this is the objective function subject to the constraint and a non-negative restriction. Anyone had any doubt? Please let me know. Yes. That this is a real problem, that first we have to identify the decision variables and to make it a LPP problem. To solve this an interval type questions, there is an another, not in only simplex, there are another methods available. By those who can solve these type of questions. Yeah, yes, yes. Okay, okay. Then come to the next problem. There is a problem that which of the following is not true in transportation problem. Generally, what we can say in transportation problem, the formulation of transportation problem involves that the number of origins should transported each origin should transport to the destination in a different destinations and to minimize the cost. The overall objective is to minimize the cost. So first one is option A is to model transportation problem so that minimize the cost, that is um, from each origin to destination, and the cost coefficients Cij and Xij are the quantity of the transported from origin I to J. So this can be the true in a transportation problem. And we can say the supply constraint is summation j is equal to 1 to n xij equal to a. That means for suppose we have destinations d1 d2 and so on dn, and origins are o1 o2 and so on om. There is an m origins and n destinations, so that here we observe x11 x12 and so on x1n. That means origin 1 to destination 1, this is the x11 is the quantity that is transported from origin 1 to destination 1. Similar way, origin 1 to destination 2, what is the quantity transported is x12. And here C11, this is the cost coefficient, that is to transport a product from one origin to one destination. Here it is the cost of that product, cost to transport that from origin to destination. And here C12 is the cost to transport the product from one origin to second destination. In a similar way, you have the cost coefficientCij's, and in a here origin 2 to destination 1, origin 2 to destination 2, and origin 2 to destination n. And here origin m to destination 1, origin m to destination 2, and m to n. So that here the total availability availability is ai to transport. Here is the availability is ai, and the demand or requirement. These requirements can be denoted as bj's, that means b1 b2 and so on bn, or bj's. J runs from 1 to n. And here ai means a1 a2 am. Here I runs from 1 to m. So in a transportation problem, the objective function is the overall cost coefficients and multiplied to the total quantity of the transport, so that we can get the minimum cost. That is an objective function. And supply constraint is here availability or supply. So here the summation of all these quantities transported from the origin I is ai or a1 from the origin 1 a1. So we can say that summation j equal to 1 to n xij is equal to ai. This is the supply constraint. So this is also true. And the demand constraint is to sum up these all, that means summation I is equal to 1 to m xij is equal to bj. This is the demand constraint. And in a transportation problem, I mean in an unbalanced transportation problem, the sum of availabilities at all origins, that means the sum of ai AI, sum of AI is equal to the sum of requirements at all destinations. What they are saying, in an unbalanced transportation problem, the sum of availabilities is equal to the sum of total requirements at all destinations. Actually, in an balanced transportation problem, we should uh, get the sum of availabilities at all origins is equal to the sum of requirements. That means when the supply, when we can supply this number of any number of quantities, then the demand should also be at the same. Then only you can get the profits. So sum of availabilities is equal to the sum of demand. So that should be in balanced transportation problem, but not in unbalanced transportation problem. So this is wrong. So which is not true means that is that option D. And here anyone had doubts? Please feel free to ask. Okay, if you are not having any doubts, then you can go to the next. You can ask in a chat box also. And the next problem is convert the given transportation problem into a balanced transportation problem. Before what we had seen that the supply, when the sum of the supply should be equal to the sum of the demand, then the transportation problem can be called as a balanced transportation problem. So they are asking to convert this transportation problem into the balanced one. Here they had the supply 300, 200 and 500 at an origins 1, 2, 3, and also the demands they had given. Let us see the sum of supply is here the 300 plus 200 plus 500 means 1000. The sum of the supply is 1000, that means the summation AI is equal to 1000, and the demand is the summation BJ, that is equal to 3 plus 2 plus 4, 900 only. So with this we can say that it is an unbalanced transportation problem. Now we need to convert into a balanced one. So to convert this into a balanced transportation problem, we need to add the dummy source or dummy destination, or the dummy source or dummy destination. Here the supply is more than the demand. So in this case, that means summation AI is greater than summation BJ. So we need to add a dummy destination in such a way that the cost coefficients are assumed to be 0. Here the cost coefficients are 30, 50 and 15 like that. So while adding the dummy destination, the cost coefficients are assumed to be 0, so that we are only balancing the total demand and total supply. Here 1, 2, 3. The sources are 1, 2, 3 and destinations 1, 2, 3. We are adding another destination. Here 30, 50, 50. Likewise here all we can add. So while adding a destination, we are assuming that the cost coefficient should be 0. So only we are equating or balancing the demand, equating to the supply. Here the supply coefficients 300, 200 and 500. Overall is 1000. To add the 1000, we here what amount of we have to add here. It is 100, so there is a requirement to add 100. The difference is summation AI minus BJ is 900. So you cannot minus here. It should be in positive, so we are adding this positive value 100. So it can be a balanced transportation problem. Now, is this understood to everyone? Whereas I mean, if the demand is more than the supply, then what we have to do? Whether we have to add a dummy destination or dummy source in case of demand is more, overall demand is more. Let you say or type in a chat box. If you understood or not, how can I know? Please respond. In case of overall demand is more than the supply, overall supply, then we need to add a destination or dummy source. Only two answers out of 34. Why means to make a transportation problem is balanced one. We can how to solve this transportation problem? We can in a detail in week 6. But here up to here we just to know how the transportation problem and what is the balanced transportation problem just to do definition one. Okay. It's a dummy source. If the overall demand is more, then we need to add a dummy source to balance the transportation problem. And coming to the next, which of the following is not true? Intersection of two convex sets is a convex set, and union of two convex sets is always a convex set. And here is a set that is a convex set, and convex hull of set is the smallest convex set containing X. What is the definition of a convex set? That is, convex set means from a set, if you take any 2 points and make a line segment, if that line segment is also contained in the same set, then we can say that set is a convex set. So here they are saying intersection of two convex sets is convex. If I suppose we can say if it is true or not. In a diagram orientation, we can take uh, in this part the intersection is this region. If we take any 2 points and then join those 2 points with the line segment, then that line is also involved in this set only. So you can say that intersection of two convex sets is a convex set, which is true. And then union of two convex sets in this way, union means the entire region, you can say it is an union if these two are the convex sets, and the union of convex sets means here I am taking 1 point and I am taking here is another point, then joining these 2 points, I mean here it will be the clear. Joining those 2 points might not be involved in the same involved in this union region. So union of two convex sets is not a convex, is may not always be a convex set. And here they are saying that they given a set is a convex set. We can prove in a mathematical way. If a set is a convex set, how can we prove this? there is a way that we have first that lambda into x1 plus 1 minus lambda into x2, these two are also uh, be the elements of this given set, then you can say that the set is a convex set. Here they had given x1 and x2, that is the two-dimensional variables are bivariate. So if we take a 2 points from this convex set, that are one point is x1 1, x2 1. This is the 1 point from the given set, and x1 2, x2 2. This is another point from the given set. Now we have to know that these 2 points and the line segment that lambda 1 x1 and 1 minus lambda x2 is involved in the given set or not. So now lambda into x1 means here x1 1 and x1 x2 of 1 point, that means x1 1 plus x2 1 is less than or equal to 4, and plus 1 minus lambda into another point. Second point is x1 2, and our convex set is less than or equal to 4. So 2. So finally with this we can tell that here only the x1. Here lambda plus 1 minus lambda. It should be equal to only x1 plus, here is the x2 point, and x2 2 is less than or equal to 4. So finally these x2 x1 2 or x2 2 are also the, initially we are assuming that these two are also the points from the given set. So the concluded remark is also in the same way. So I can say that this set is also a convex set. And we know that the convex hull is the smallest convex set containing the convex set. This is also the true. Finally, the option B is correct. And any doubts in this? Okay, let's move to the next question. Here is the question that if a constraint has less than or equal to sign, then in order to make it an equality, what we have to do? I think we all can answer this. I am leaving this to you. Let's see how many of you can answer. Am I audible to all? Okay, then answer it. I am seeing all of their answers in chat box. Two of you said B. B means that is slack variable to the left hand side of the constraint. Okay, any answers? Any different answers? Another new one is subtract a surplus variable from the left side of the constraint. And more expecting to answer all of you. I'm asking you the correct answer, not the different answers. Okay. Some of you said B. Who said B is the correct? Why? Because for suppose that if a constraint is 5x1 plus 3x2, less than or equal to 10. So to make this constraint into the equality, why? Since we are converting the given LPP problem into the standard LPP, then we need to convert the given constraints into the equation in such a way that if the constraint is less than or equal to type, that means here the left hand side is somewhat lesser than the 10. So we need to add a quantity. That means here we are denoting that quantity is a slack variable. Adding a variable, that means here it is a slack variable to make the inequality into equation. For suppose 5x1 plus 4x2 greater than or equal to 8, this means it is the greater than or equal to constraint. So to make this into an equation, um, here with this constraint what we can observe is the 5x1 plus 4x2, this amount is more than 8. So to balance that, we need to subtract this old quantity with a with any other variable. That is, we can call it as a surplus variable. Here 5x1 plus 4x2 plus let us denote x4 is the surplus variable. So here it is a slack variable. Since we are adding this and subtracting variable, you can sell it as a surplus. I assume that you all understood why we add in left hand side to the left less than or equal to constant, because it is somewhat less, so we need to add to balance. Okay, is everyone understood this? Coming to the next problem, I next, a feasible solution to the linear programming problem should satisfy the problem constraints or optimization function, or to satisfy problem constraints and non-negative restrictions, or satisfy the non-negative restrictions. I am expecting to answer you. I think you are all aware of this. This is a just basic definition to the feasible solution in an LPP. What are your expected answers? Just to think, in an LPP, what we have? In an LPP, we have objective function and subject to the constraints and also the non-negative restrictions. But a feasible solution must satisfy which of the following options? Who said the option B is not correct? Since optimize the objective function means the best feasible solution, we can say it is an or optimal solution, you can say that is a optimize the feasible solution. But generally the feasible solution must satisfy all the problem constraints and also the non-negative restrictions. Both it has to be satisfied. That is a feasible solution. Option C is correct. Is everyone clear up to this? Okay. Coming to the next problem. Here is they are asking to solve the given problem. So that option is unique, unbounded, or multiple solutions, or infeasible solution. Um, I guess you all may aware that in an LPP problem, when there are only the two variables, we can solve this with the graphical method easily than the simplex method. So you just start doing the graphical procedure to the given problem. What should be the your answer? I tell you the what is the graphical solution procedure. Um, First thing is in a graphical procedure. First we have to um, just change the given constraints into the equations. Just to change, not converting. Just to change the constraints into equations. First thing is constraints into equations. And next thing, for all those equations, we need to find out the um, graphical points to plot the graph. That means first we have to assume that one variable is 0. Then we need to solve then another variable from the one equation, and also in another equation in the same way we have to find out. And next we need to assume x2, another variable is 0, and we have to find that x1, so that here we can obtain the x1 and x2 points. And after that we need to plot these x1 x2 in a graph. And third step is, if the constraint is less than or equal to type, then we need to shade the region towards the origin. And if it is greater than or equal to sign, then away from the origin. So in the given problem we can see here the constraints are 2x1 plus 3x2 less than or equal to 18. So we are just changing the given constraint into an equation, and 6x1 plus 5x2 is equal to 60. Now in this equation, first we are assuming that x1 is equal to 0, so that x2 is equal to what is the x2 value? Answer it in a chat box. Okay, some of you had done, but to know the others. So if we substitute x1 equal to 0, then from this equation x2 is equal to 6. And next x2 is equal to 0, then x1 equal to 9 in the first equation only. So here we are obtained the points 0, comma 6, and here 9, comma 0, x1, x2. And from this equation, first we assume x1 equal to 0, so that x2 equal to 12. And then x2 equal to 0, then x1 equal to 10. In this case, 0, comma 12 is the point, and in this case 10, comma 0 is the point. Now we need to plot these points in the quadrant, and to x1 maximum is 10. We should assume here is an x1, then it's an x1, here is x2, 6, and here we assume that 12. So first point is x1 0 and x2 is 6, and next x1 is 9, here it is 9, and x2 is 0. So to combine this line And here in the first equation the constraint is less than or equal to sign. Here it is the less than or equal to sign. So we need to shade towards the origin. Here I told you that if the less than or equal to constraint, shade towards the origin. And in the same way, if we plot x1 equal to 0 and x2 is equal to 12, and here is another point. Now this is the constraint is greater than or equal to sign in this equation and second equation inequality. Then we need to shade away from the origin. So there is no common region in this shaded region. So we can say that it is an infeasible solution. In case of multiple solutions, in these points you can obtain more number of same maximization object or minimization. And unbounded solution means if we plot the same way, we can get the common region, but the objective function should be indefinitely increased or decreased. And unique solution means the solution optimal feasible solution should be only the one, then we can say it is a unique solution. In this case, ours is feasible solution. Okay. Next, coming to the next problem. Here they had given a simplex table for an LPP, and what of the given options is a combination of entering and leaving variables. So let's start doing. Uh, to know what is an entering variable, what we have to do is deviation step. Entering variable means maximum deviation entry should enter, and leaving variable means we need to find the minimum ratio test. Then we can get the what is an entering variable and what is a leaving variable. In this case, how you can find out the deviation entries? To say that deviation entry is delta j, the delta j is equal to Cj minus summation C naught into xp for here xj. So here for the first okay, for the first Cj here we had an 5. So delta 1 is equal to 5 minus summation C naught into xj means 0 into 1 and 0 into 3 plus 0 into 2. Finally we get 0, here it is a 5. So here we obtain the 5. In the same way 2 minus 0 into 2, 0 into 4 plus 0 into 3. Finally we get only 2 and here we get 3. In this way you can easily say that 0. And these are the deviation values. Now we need to find out what is the maximum deviation value. Here it is the 5 is the maximum deviation value. So x1 is the entering variable into the basis. Now we need to find out what is the leaving variable. So for a leaving variable, we need to find out the minimum deviation value. Sorry, minimum ratio test. So here minimum ratio should be xb by and corresponding aij values. That means the availabilities which are available in the pivotal column. Here x1, the column containing elements is can say it as a pivotal column. And also xb should be greater than 0, greater than or equal to 0. So here xb is in the first row, xb is 8 and given aij is 1, so the value is 8. And similarly 7 by 3 is equal to 2.3 and 10 by 2 5. here we need to get a minimum ratio test. So minimum of these is 2.3. So we can say that x5 is a living variable. The option 3 is correct. Is everyone able to get this? Okay. Next, moving to the next problem. Question 9. For maximizing an LPP during the simplex procedure, the criteria for a variable to enter into the basis is. Just now only I told you. Please respond your option. What should be the answer for question 9? What is the answer for question 9? In the previous problem only, I told that what how we can proceed. Here, what they have given criteria for variable to enter into the basis. That means what is an entering variable? That means a variable. If a variable to enter into the basis, what is the criteria? In the previous problem, here we obtained that x1 is an entering variable. Why? It has the maximum deviation value as compared to the others. So x1 is here x1 is an entering variable because of the criteria is maximum deviation entry. So for this problem, the maximum deviation entry is for the criteria to enter a variable into the basis. Here the minimum ratio test is for the living variable. For a living variable, we need the criteria of minimum ratio test. There is no meaning to maximum ratio test and minimum deviation. Okay, up to this, anyone had doubts? All of my questions were over. If you have any doubts, we can discuss. Otherwise, I just leave the meeting. I am welcome you. Yes, ask others to be. Rank. Okay. Linear programming problem we are solving in a rank method, right? Linear programming problem. Rank. Where where is the rank here? Or this. Okay, okay. In that way also you can do. No problem at all. To solve a single problem, we had so many ways to solve. We are saying, hmm, actually I am not aware of this rank method. If the rank method gets the solution of entire simplex processor, you can proceed in that way. And is there any doubts? Then next week concepts are, I think you are aware of those. One is big M method and two-phase LPP and the different solutions of an LPP. Is right? Okay, then we can discuss in the next week that from the next week syllabus. So up to this week, we have covered all the questions from each topic. Okay. I am leaving from the meeting. Is there any question? Okay, thank you. I am going to terminate the call.